this design came from. This is not just something that I whipped up. All right. So Lambda in 2020. I'm a little bit annoyed because AWS have like claimed this word Lambda, which is it's a much older word that kind of refers to an anonymous function in functional programming. But AWS have taken this name Lambda to mean some code that you can run in the cloud without having to do any kind of server management. I'm gonna talk about it from. Okay, first dodgy thing with this pitch.com. It's a little bit laggy. I'm going to talk about it from my experience, but I'm by no means an expert. I don't have any AWS certifications. This is so we spent a year or two building these kinds of systems in my previous role, and this is what I learned from it. If you go onto the internet and do some research into serverless, especially on Hacker News, there's like all kinds of opinions. Common one is like, yeah, I just don't like serverless. And on the same page, there'll be like 50 other people saying serverless is the best thing ever. It's kind of a hard thing to quantify, and it's kind of a hard thing to lock down. Some people would call Heroku serverless. Some people would call Heroku not serverless. For this talk, I'm like mainly referring to AWS Lambda, which is just this like really specific, in other words, cloud functions. So I'm talking about cloud functions, and I think that they have their uses and they also don't. And we'll talk about that a little bit more. Like Igor said, my background is in medical devices at CMR Surgical. We were doing a bunch of different things. And that's what I'm going to focus on mostly in this talk. I'm going to talk about one of the big projects that we built, and it was all built on serverless. And then earlier this year, I started a new project, making these serverless things easier to build, and that sort of came out of what I learned from CMR. So we'll look at that. What were we doing? So, put really briefly, we were processing large files that were left in AWS. So we were building this robot, and the robot would upload data files to S3 or something, and then we would run some processing steps on those files, and then do some data science, and then we would get some outputs on the end. And we wanted to do it all serverlessly because reasons. I think there's some naivety, and I think that maybe there's some craziness that we decided that we wanted to use AWS Lambda and we wanted to use serverless tech because it seemed like it was the best way to do it. We'll see how there's some trade-offs. But anyway, we were building something that looked a little bit like this. So you've got your robot, and it's uploading some data to S3, and you get your data file. And you want to, the goal at the end is to do some machine learning or some data science. But to get there, you have to do a bunch of intermediate steps. So for example, firstly, you need to split your file into a large number of chunks. Then you need to compute something on each of those chunks. Now, you can imagine that something could be some like long-running process. This could be many things. So for example, if you've got a video file, you might want to chop your video file into many thumbnails, and then do some kind of vision processing on those thumbnails, and then do many of those transformations. And at the end of that, you want to take all of your individual chunks, and you want to combine them back into one, and then do something with that final chunk. So it's this sort of like stepwise process, and people call this like a data pipeline. And there are like so many ways of making data pipelines. But we thought, hey, we're smart. We want to do something smart, whatever. So we used Lambda to do this, which was interesting, and it worked, but it's hard to build. And this is the bulk of the presentation that I'll talk about. So this is the kind of interesting bit where if you've got a big if you want to do some data processing in AWS, would you use Lambda? Why would you use Lambda? And what are the things to watch out for? So to break the problem down into something simpler, let's look at the case where we have just 3 functions that we want to run on our data. So we have some piece of data that arrives at the top, and all we need to do is call 3 functions, one after another. And these are functions like literally just a Python function that does some data engineering on our thing. There are a few ways that you could do this in Lambda. The basic principle with Lambda is that you can take your piece of Python code and like dump it inside a Lambda function and trigger it on a network request. And so you can pass pieces of data from one Lambda function to the next by just calling a network API. This gets complicated, and I guess you can imagine. So if g of x fails, and you weren't expecting that, you're going to get a stack trace in g of x, and your pipeline will just fail halfway through, and you'll have no context about what happened in h of x to cause g of x to fail. So you've already lost some context, and that's almost the simplest example that I can think of where it becomes really complicated to keep track of these things. So anyway, it's totally possible, and the trick is to put these queues in between each function. So what we did is we built these little modules where there was a Lambda function with an input and output queue and something called a dead letter queue. And the dead letter queue is where the failures go. So if one of those functions falls over, the result gets put into a dead letter queue, which can then be picked up by some other system. So that's like exception handling. So we're going to talk about infrastructure as code in a sec, but we built each of these individual pieces, each individual pieces of infrastructure, and then we tied them together. How do you build each of these individual pieces? So infrastructure as code, I guess most people have come across it, know what it is. Just in case you haven't, infrastructure as code lets you describe your cloud infrastructure in some kind of text language, which then you put into your version control, and that's great because now it's versioned, and it means that you can create multiple replicas of that environment. Infrastructure as code is totally great. There are a few different kinds of infrastructure as code, and you're going to come across CloudFormation. So if you're ever doing anything with Lambda in AWS, you're going to have to learn CloudFormation. It's unfortunate because it's slow and it's hard to use, but it's everywhere. CloudFormation is like the de facto infrastructure as code for AWS. You can't get anything done without, in the end, using CloudFormation. So that's not quite true. Many of the tools that allow you to automate your AWS account end up generating CloudFormation code, and the AWS console integrates quite nicely, and you can visualize what's happening. Anyway, that's one option. Another kind of infrastructure as code. This is the approach that we took. So we used Terraform to manage our infrastructure, and it worked really well for us, actually. It's got some real problems, which we can go into a little bit later, but Terraform actually made a lot of this process a lot easier for us. So the nice thing with Terraform is, if we remember those Lambda blocks, we've got each individual module, each little block of infrastructure that have to be connected. So Terraform lets you build those kinds of abstractions fairly well, and you can create these blocks of infrastructure, and you can compose them, and you can connect them. So it's good. I think the general consensus with the community, I think the general consensus is that it's lacking in many ways. The language is not ideal. there are many things that you can't do with Terraform, and it can be painful doing simple things that you would expect a programming language to do. But it's the best that we've got at the moment, I would say. So I would say if you want to do infrastructure as code, go for Terraform. It worked well for us. This third kind of infrastructure as code is almost not infrastructure as code, but is probably the best thing to use if you're just getting started with Lambda. The serverless framework, everyone, most people who've used cloud or serverless have come across this. It's quite old. It's been around for a long time. It's probably the best. Yeah, it's probably the best way to get started with Lambda. It doesn't scale too well in my experience. I know that some people have built big projects with serverless framework, but my experience has been that it gets hard to iterate past a certain stage. I think it slows down development substantially. I think a lot of this comes down to when you want to use Lambda and when you don't want to use Lambda. And of course, we're here trying to compare serverless and Lambda with Heroku, and that's kind of the key question. I think so. Okay, the cop out, the get out of jail free answer is that you can't compare Lambda with Heroku. They're two very different things, and I think that's true. But I think they get confused quite a lot. One of the original purposes of Lambda was to be used as glue logic, and I think that's still what it should be used for primarily. So the use case that we use it for at CMR, like this data pipeline thing, that worked well, but it was really hard to implement, and arguably it wasn't the best tool for the job. What do I mean by glue? So if AWS have a whole lot of services and one of them doesn't behave the way that you want it, you write a Lambda function to wrap that service and to do something. So it's like Lambda is the tool that lets you fill in all of the gaps in your infrastructure. And contrast that with using Lambda to run all of your business logic. So why am I saying that? There are a lot of complexities around using Lambda. Complexities in terms of how the infrastructure is provisioned, how the infrastructure behaves, and there's a lot of details that we can go into. But what serverless gets right is it wraps the basic interface really, really well. So that's why I said serverless works well for small things, where if you've got a couple of API endpoints, you don't need a database. You just need to spin up a get HTTP endpoint very quickly. Serverless framework will totally do that for you. Now, if I compare that with Heroku, where I want to have a database and I want to have a web service and I need it to work, I want everything to work quickly. Those are two very different use cases, where one is a full stack application, and one is just like these small little microservices that don't do very much. So at the moment with plain AWS Lambda, simple Lambda, I wouldn't use it for the business logic. There are too many issues around how it works. Cold starts. So cold starts essentially is where if you haven't called your Lambda for a long time, the first time you call it, it'll take a while to start up, because the AWS is essentially booting up the virtual machine for you. And there's a timeout limit on how long your function can run for, and if you overrun the timeout, if you overrun that time, it just shuts down. Great. So a few of the tips I think for this is slightly more general. Infrastructure as code. AWS is just really complicated. So prototype everything in the console first. Learn how to use the service. So if you're trying to configure something with infrastructure as code, learn how to use the service first via the console. Like take notes, like figure out all the buttons that you had to click and everything that you had to configure, and then translate that into your infrastructure as code. And you're going to have to keep going back and forth between the console and the infrastructure as code, because it's never obvious how it's meant to be configured. Use multiple environments for testing. So have your production accounts, I would say have per developer accounts. If you're doing stuff with Lambda, you want per developer accounts, so each developer can spin up their own instance of the complete environment. Again, this is something that is very specific to AWS and serverless because of the complexity and because of the nature of it, which I don't think you get, or at least you get less of if you're using a service like Heroku. But do use it, I guess, in summary. It does let you fill in all of the gaps very, very well. Just be careful with as you use it. Oh, all right. I'll mention this one very, very briefly. So there's this Amazon have released a bunch of tools for helping you build serverless and Lambda, and this little guy on the right here is called the AWS SAM, which is a serverless application model framework thing. I wouldn't use that personally, but and I think I'll skip past this slide because it's a little silly. I'll leave you with a rocket ship for building cool stuff. Now I rushed through that, so what would we like more detail on? Oh, Mo has asked about SAM. What are my thoughts on SAM? Honestly, I think it's like the worst developer experience tool I've ever encountered, in summary. And I know it's like so much engineering has gone into it, which is a real shame. I really would love to be able to use it. I don't even have a good reason why it's such a bad experience. I think it's probably partly because it's based on CloudFormation, and CloudFormation sucks. If SAM wasn't based on CloudFormation, it would probably be a much better experience because it would be fast. Yeah, why does it suck? I really like, so SAM, I guess for context for everyone else, so SAM allows you to describe your application in a conventional programming language, which gives you actually really nice abstractions, actually. So to be fair on SAM, the abstractions are really, really nice. I like them a lot. I think it's probably the CloudFormation the underlying framework is yeah, painful, I guess. So when I'm developing something, right, there's a few things. How long is my testing cycle? That's probably the biggest thing to consider. And certainly with SAM, I was getting really slow. The iteration speed was really slow. How do I test in development? Yeah, so the general wisdom here is so if you've got two parts, the part that you test is this guy, which is like all of your business logic, and then the AWS Lambda bit just sits just over it. So the logic that's in the Lambda function should be extremely tiny, or 0 if possible. So the idea is that you should be able to test all of your functions individually outside the context of Lambda. Now that doesn't always work because because software is hard, and you end up having to leak some state and things. But do that as much as possible. So keep your Lambda handlers really, really thin, and just call out to library things. And have a good data access model. So abstract your data access very well. Yeah, Fargate's great. I don't really know Google Cloud, so I can't really comment on Google Cloud, but Fargate's great. I haven't done a good cost analysis on Fargate. That's my one worry with Fargate. I haven't figured out how expensive it is compared with the other available platforms. But yeah, Fargate works well. Is there a best language to use for Lambda functions? I would say JavaScript or Python, mainly because they're the most supported. And when I say JavaScript, like Node, of course.
Any more questions from anyone? Nope, not at all. Not a single one. Okay, thanks, Rick. That was really, really great talk. Thank you so much. Super insightful. And yeah, we all learned a lot on Lambda and the quirks of it, and yeah, the glue and the glue. Cool. Thank you, Rick. We had our 2 awesome talks, and now is the time for a real, hopefully fun hangout in a platform called, we call it Virtual Drinks, so everyone's welcome to grab a drink, of course. We'll be running that in a platform called High Fidelity. Yes, here is the link. So everyone is welcome to